Hey, so this week we'll be covering confidence intervals. So let's start with this quick primer. Assuming we want to estimate the average amount freshmen at the University of Arkansas spent on textbook in the fall of 2019. Remember, our population parameter is mu. Mu would be the average amount all freshmen spent on textbook last semester. But mu is usually unknown because to get mu, we would have to collect data from the entire population. But now let's assume we take a random sample of 150 freshmen and we found that average amount they spend on textbook to be $285. $285 is our sample statistics. You all remember what M is. M is a sample mean. Can I make a claim that the average amount all U of A students, U of A freshmen spent on textbook to be $285? Can I claim that this population parameter is $285? Why or why not? You can pause this video and think about it for like 10 seconds, then we can continue from there. But I'll continue. Now let's talk about confidence interval. So confidence interval is a range of likely values for the population parameter. So what this is saying is the confidence interval is a range of plausible values that the population parameter could be. So we are given this instead of saying that the true amount U of A students spent on textbook is 285. We want to give a range of values that we think this population parameter would contain. Is so this confidence interval is based off of some three key elements. It is based off of your sample statistic, which is it could be your sample mean, and it's also based off of your standard error of the statistics. We'll see what this means in a bit. And it's also based off of the investigator's desired confidence level. So your confidence level could be 90%, 95%, and 99%. We'll see what those mean in a bit. So our statistic is from our observed data is our best guess. So that's where we're starting from. That's why one of the elements for the confidence interval is our sample statistics. That's our first best guess. Then we could use that sample statistics to create a range of plausible values. So the confidence interval provides more information than the sample statistics. So instead of relying of just on this guy alone, you want to create a range of plausible values that you think the population parameter is. So our confidence, let's talk about what the confidence level is. So the confidence intervals are constructed at a confidence level, and confidence level is related to the significance level which you use in hypothesis testing. So to make decisions on what values are plausible, we would use the confidence level to make this kind of decision. That's why it is one of the key elements of the confidence interval. That's what we had in the third bullet point here. So confidence level intervals correspond to significance level. So this should say confidence level corresponds to significance level. So a 95% confidence level corresponds to 5% significance level. And a 99% confidence level corresponds to 1% significance level. So if you notice, they sum up to 100%. So in hypothesis testing, we use this a lot, the significance level. So in confidence interval, we would use the confidence level. So the larger the confidence level, the larger the range of plausible values. So for 99% confidence interval or confidence level, you would see more plausible values under the 99% compared to the 90%. We'll see some examples coming up. So remember I said the confidence interval is your range of values. So something like what we saw earlier, if you had the confidence interval to be, let's say, 250 to 300. So this would be the range of plausible values that we think the true amount all U of A students spent on textbook should be. So we think the true amount should be between $250 to $300. So A is our lower bound and B would be our lower bound. So your values should be in intervals. So always write your values in parentheses. Okay, so let's continue from there. So, what is the general formula for the confidence interval? So, the general formula is your statistic, which is maybe your sample mean. Now, we saw this critical value when we did hypothesis testing. So, you need to add and subtract the statistics from, you need to subtract your critical value times your standard error of the statistics from your statistic. We'll see what that means in a second. So the critical value depends on the confidence level, just like when you did hypothesis testing. Your critical value depended on your significance level. So it's just very similar here. And also, when you're working with t distribution, it depends on the degrees of freedom. Like you already know, the critical value for a 95% confidence level or confidence interval is different from that of a 99%. It's also different from a 90%. So each confidence level has its own critical value. Okay. So the margin of error is just the critical value times your standard error. So think of it, assuming someone tells you that now we're in election is coming up, you watch TV a lot, you see a lot of news about who the voters think would win the election. So let's say the president's current approval rating is 48%, right? So let's say 0.48 or 48%. And you see something called the margin of error. So the margin of error could be plus or minus. So let's say this is 48%. Ignore this period here. And let's say the margin of error is 2%. So 2% just means his approval rating could be as high as 50%, and it could also be as low as 46%. So that's what the margin of error is. So the margin of error is just the critical value times the standard error. So the margin of error in this case would just be 2. So we'll see what those are coming up with as well, how to find the margin of error and the other good stuff. Okay, so let's start talking about the different confidence intervals that we have. So just like when we did the hypothesis testing, we had the one sample z test. We also have the one sample z statistics confidence interval. So remember, when you use the one sample z statistic, it is when your population standard deviation is known. So if your population standard deviation is known and you want to estimate the range of plausible values for the population, this is the formula for the confidence interval. So the formula here is simply m, which is your sample mean, plus or minus the critical value times the standard error. Again, this is your sample mean, your critical value, then you multiply that to your standard error. But the good news is the critical value for the confidence interval when we're dealing with z distribution, they are fixed. Remember, it doesn't depend on the degrees of freedom. So for a 90% confidence level, the critical value is plus or minus 1.645. For a 95% confidence interval, the confidence level, the critical value is 1.96, but there's a plus or minus in front of it. And for 99%, it is 2.576. So just like we said earlier, as the confidence level increases, so does your critical value. So that is why the larger the confidence level, the larger the range of plausible values. Okay. So let's delete that. Okay, here you go. 1 second. Here we go. Okay. So also we have the one sample t statistics. The t statistics for one sample, assuming we only have one quantitative variable and we don't know what the population standard deviation is, then we would use the one sample t statistics. And the goal of the confidence interval is to estimate the range of plausible values for the population parameter. So this is what the formula is, very similar to what you saw for the one sample z statistic. But in this scenario, the critical value here depends on the degrees of freedom. And the degrees of freedom for the one sample t statistics is n minus 1. So that's why you don't have fixed values here. Just for the z statistics or z distribution, our critical values are usually fixed. We know them because it doesn't depend on, this is for the z, it doesn't depend on any degrees of freedom. And but for the t, it depends on the degrees of freedom. And that is what we have here. So you would need to use your z table or your t table in this case to find your critical value. We'll see examples coming up. And for the independent sample t statistic, this is what the confidence interval looks like. So we have m1 minus m2 as our test statistics, plus or minus your critical value again, which depends on the degrees of freedom. The degrees of freedom in this case is n1 plus n2 minus 2, which is the sample size for group 1, sample size for group 2, then subtract 2 from the sum. And your standard error, this is what your standard error looks like. Okay. Then for the dependent sample t statistics, so we have um, MD. Remember, MD is your mean difference. You did this before your midterm. This is your mean difference, then your critical value times your standard error. SZ is the standard error, standard deviation of the mean difference. Okay, and n minus 1 is the degrees of freedom for the dependent samples t statistic. Okay. So how do you interpret your confidence interval? So whenever at the goal of the confidence interval again, the confidence interval estimates the interval of the true mean or the differences. So you would say we are 95%, assuming the 95% confidence interval, that's what we calculated. So you would say we are 95% confident that the true mean, or if you did the differences, then or the differences in the true mean is in the interval we found. That's the way you would interpret the confidence interval. So we would stop here, and you can watch the next video for examples on how to calculate the confidence intervals.